Welcome, and thanks for joining us today. In this session, we're walking you through what's new in IPC Firmware version 5.3.1, a release packed with meaningful updates across AI analytics, cloud connectivity, image settings, and remote access. Whether you're an installer, integrator, or distributor, there's something in here that's going to make a real difference in the field. Let's get into it.
This firmware update is supported across our S-Sight, I-Sight, and Smart IP camera ranges. On S-Sight, all hybrid, including the Wi-Fi variant, Rainbow 3.0, and active deterrence models. On I-Sight, all v5 models and the panoramic series. On Smart IP, all LPR models with the half-inch sensor, specifically the i6220 and i6240 LPRN MVF models. If your cameras are currently running firmware version 5.2.3 or later, they're compatible with everything covered in this webinar.
This firmware introduces cloud binding, the ability to connect an IPC directly to the Cam2 mobile app through Provision-ISR's cloud service. Cloud binding unlocks three key benefits that we'll cover in the next slides: event push notifications delivered directly to your phone, over-the-air firmware updates, and secured access for P2P connections. But first, let's understand how to get there. There are two steps. First, enable the cloud service on the camera under Network, Advanced, NAT. This connects the camera to Provision-ISR's cloud server. But enabling alone doesn't give you anything yet. The second step is the binding itself. Scan the QR code using the Cam2 app and enter the security code shown on the same page. That's what links the camera to your Cam2 account and activates everything. No binding, no benefits.
Once the camera's bound, it appears as a device in the Cam2 app, ready to live view and receive alerts. Event notifications are pushed directly from the camera to your phone in real time. Loitering detection, motion detection, AI alarms, they all land straight in the app the moment they trigger. And you stay in control of what you receive. Head into the notification settings and toggle each alert type on or off independently. AI alarms, motion detection, sensor alarms, and device fault notifications can all be configured separately. Only get notified about what matters. The second benefit of cloud binding is over-the-air firmware updates. When a new firmware version is available, the cloud server detects it and sends a push notification straight to the Cam2 app. No need to manually check for updates. From the app, simply accept the update. It downloads and installs directly on the camera. No site visit required, no file downloads, no manual steps. For those who prefer it, the update can also be triggered from the camera's web interface under Maintenance Upgrade. The cloud upgrade option is available there alongside the standard local upgrade method. The third benefit of cloud binding is secured access. And if you're already familiar with this feature on our NVRs, it works on the same principle, now brought to the IPC. Once a camera is bound to a Cam2 account, any P2P access attempt requires an authentication code. The camera owner stays in full control of who gets in. Here's how it works. If, for example, an installer requires remote access to the camera, they navigate to provision-isr-cloud.com and log in with the camera serial number, username, and password. Instead of getting straight in, they're prompted for an authentication code. At that moment, the bound user receives a push notification on their Cam2 app, a login request showing the camera name and time of the attempt. They tap Allow, an authorization code is generated, and they share it with the installer. The installer enters the code and gets access. Simple and secure. The owner never has to share their password. Every access attempt is notified and approved in real time, giving your customers full visibility and control over who accesses their system, even after installation is complete. One important thing to be aware of before we move on: if a bound camera is factory reset, the cloud binding is not removed. This is intentional. It's a security measure to prevent unauthorized unbinding. There are two ways to unbind correctly. The first is through IP Manager version 1.1.0.20 or later. Find the camera on the local network, use the Unbind Cloud Account option, enter the MAC address, and power cycle the camera within 30 seconds to complete the process. The second method is simpler. Delete the device from the CAM2 app, and it unbinds automatically. Worth knowing before your next installation. Direct Camera Web Access is a new feature designed specifically for when you're accessing an NVR remotely via its P2P web interface. It allows you to open an IPC's full web client directly from within that session without needing to know the camera's P2P serial number or local IP address. This is made possible by the IPC now supporting Provision-ISR's cloud services. Here's how it works. When logged into the NVR's web client remotely via P2P, head to the Edit Camera section. Click the settings icon next to any camera, and the camera's full web client opens automatically right from within the NVR session. The behavior depends on whether the camera is bound or not. If it's not bound to a CAM2 account, the web client opens straight away with no additional steps. If it is bound, secured access applies and an authentication code is required, exactly as we covered in the previous slide. One quick but important note: for this feature to work, two conditions must be met. The camera must be connected to the NVR by IP address, and the camera's NAT service must be enabled and showing as online. Without both in place, the bridge between the NVR and the camera's web client won't function. Event Trigger Sensitivity is a new setting that controls when an AI analytic rule fires. When the AI detects an object, it draws a bounding box around it. This setting determines how much of that bounding box needs to be inside the ROI before the event triggers. It is available across most all AI analytic rules: line crossing, sterile area, loitering, illegal parking, and more. Let's look at how the sensitivity levels work in practice. At high sensitivity, even a small portion of the bounding box entering the zone is enough to trigger. At low sensitivity, the object needs to be substantially inside the zone before anything fires. This setting is particularly useful for eliminating false alarms caused by objects grazing the edge of a detection zone, and for tightening detection in scenarios where you only want to trigger when an object is clearly and fully within the area. Let's talk about loitering. Loitering doesn't always look the same in the real world. Sometimes a person loiters by standing completely still, not moving, just present in an area where they shouldn't be. Other times, a person loiters by slowly walking or pacing around inside a defined zone. With the introduction of trigger mode, loitering detection can now be configured to match both scenarios. Set it to moving object, and an event only occurs if the target exceeds the time threshold while actively moving. This is ideal for scenarios like clothing stores, where mannequins could be perceived as humans and trigger false loitering alarms. Set it to all objects, and an event occurs when the target exceeds the time threshold, whether they are moving or completely stationary. And it doesn't stop at loitering. The same trigger mode options are available across sterile area and line crossing rules as well.
Area-based detection control introduces granular control over AI analytics alarm area rules. AI rules such as line crossing, sterile area, loitering, and illegal parking all support up to 4 independent alarm areas per rule. Each area can now be independently configured with its own detection object type, minimum and maximum object size, and sensitivity level. For example, a line crossing rule covering a building entrance with 4 lines, each tuned differently based on distance from the camera. Close to the camera, objects appear large, so a higher minimum size and lower sensitivity may be appropriate. Further away, objects get smaller, so size thresholds and sensitivity levels need to adjust accordingly to compensate. Each area independently tuned to match exactly what it needs to detect. The GUI is straightforward. At the top, you select the alarm area you want to configure. In this case, the rule supports 4 independent areas, numbered 1 through 4. For each area, you'll find 3 sections. Detection object, where you choose which object types to detect and set an individual sensitivity level for each one. Event detection, which controls how much percentage of the bounding box must be inside the ROI to trigger an event, and object size, where you define the minimum and maximum width and height for the selected object type. Switching between alarm areas shows a completely different set of configurations for each, confirming that every area is truly independent.
Previously, motion detection applied a single sensitivity level across the entire defined area. Now, each zone within the field of view can be configured with its own sensitivity threshold, giving installers precise control over how the camera responds to movement in different parts of the scene. This is particularly useful for managing perspective and reducing false alarms. Zones covering distant areas, where moving objects appear smaller and affect fewer pixels, can be set to higher sensitivity to ensure nothing is missed. Zones closer to the lens, where minor movements like animals or foliage are more likely to trigger unwanted alerts, can be set to lower sensitivity to filter out the noise. The result is a smarter, more accurate motion detection setup that adapts to the real-world conditions of any installation. The GUI is straightforward. The camera's field of view can be divided into independent zones, drawn and defined by the user. Each zone is assigned its own sensitivity level using the slider on the right, and the color of each zone reflects the sensitivity level set for it. You'll also notice the SMD section at the top. Smart Motion Detection adds an object filter layer on top of zonal sensitivity, allowing you to limit alerts to humans or vehicles rather than triggering on any pixel change. It's not the feature we're focusing on here, but it works alongside it to give a more complete and accurate motion detection setup. The OSD settings now give full control over how text appears on screen. Font style, size, color, and transparency are all configurable. Font size is self-adaptive by default, so it scales automatically without manual adjustment. The big addition is Picture Overlay, brand new in this firmware. Upload any image and it displays directly on the live camera feed. And this is where it gets interesting for you as a system integrator. Overlay your own logo on every installation you deploy, and your brand stays visible to your customer every single day, giving your work a white label feel that sets you apart from the competition. A simple but welcome improvement. Video masking allows you to define specific areas within the camera's field of view that you want to permanently obscure or block out in the video feed. Those areas are covered by a solid colored block, so neither live viewers nor recorded footage can see what's behind the mask. Why it exists? It's primarily a privacy compliance tool. For example, a camera covering a car park might accidentally capture a neighbor's garden. You mask that area. GDPR and similar privacy regulations in many countries require that cameras do not capture areas they are not permitted to record. Masking is the practical solution. How it worked before? The masked area was always displayed as a solid black rectangle, functional but visually obvious and inflexible. What's new in this firmware? The color of the mask can now be customized, so instead of an obvious black block, the installer can choose a color that blends more naturally with the scene or matches a specific aesthetic requirement from the end customer. Privacy masking now supports scheduling, meaning masks can activate and deactivate automatically based on a time schedule you define. Think about a retail store camera that covers a shop floor but also captures a neighboring residential street through a window. During business hours, the full scene is visible and the camera operates normally. After closing time, the mask activates automatically, blocking out the residential street and protecting residents' privacy overnight. No manual intervention required, the camera handles it on its own schedule every day. Simple, automatic, and fully compliant. Environmental noise filter is a new audio setting that improves the quality of audio captured by the camera's built-in microphone. It offers two modes. Normal mode applies standard audio processing and is suitable for most indoor installations where background noise is not a concern. Enhanced mode applies stronger filtering, designed specifically for outdoor or noisy environments. Wind noise, traffic, construction, rooftop installations, anywhere where constant ambient noise makes the audio difficult to listen to. No additional hardware required, just a simple setting change that makes a real difference in challenging environments.
Substream now has a new 16:9 resolution option, 640x360. A 16:9 substream option already existed at 1280x720, but at that resolution, bandwidth consumption on the substream could become a concern, particularly in remote viewing or mobile streaming scenarios where bandwidth is limited. 640x360 maintains the same native 16:9 aspect ratio, but at a significantly lower resolution, meaning less bandwidth, less strain on the network, and a cleaner viewing experience on widescreen displays without any digital stretching. For installers working in bandwidth-constrained environments, this is a practical and welcome addition to the substream options.
HTTP notification is an existing feature, but this firmware brings some meaningful additions, particularly for anyone doing third-party integrations. First, there are now 2 API command versions to choose from. v1 maintains compatibility with existing integrations built on the previous command structure. v2 supports the new optimized API, relevant for anyone building new integrations or working with platforms that support the updated structure. On the connection side, short connection has been added alongside long polling. The two work differently and suit different scenarios. Short connection opens a session, sends the data, and closes immediately. It's lightweight, simple, and well-suited for event-based notifications, where data is sent occasionally. Long polling keeps a persistent connection open for continuous data exchange, making it faster and more efficient when there's a constant stream of events to push. To keep that connection stable, a heartbeat interval acts as a keep-alive ping. If no response is received within the set interval, the system knows the connection has dropped and can recover accordingly. As a general rule, use short connection for infrequent events. Use long polling when you need a real-time, continuous feed into a VMS or third-party platform. DDNS, or Dynamic DNS, allows you to access a device remotely using a fixed domain name even when its public IP address changes. For installers, this means your customer can always reach their camera system remotely without needing to track a constantly changing IP. This firmware adds a test button directly to the DDNS settings page, and the experience differs depending on which provider you use. If you're using Provision-ISR's own platform, autoddns.com, the process is seamless. Enter your domain name and hit Test. That first click both creates and registers the domain in one step. Every test click after that simply verifies the connection is live. For third-party providers like NoIP, DDNS, or others, create your profile on their platform first, input your credentials into the camera, and use the test button to confirm the connection is working. Either way, you get instant confirmation before saving. No more guessing whether your DDNS setup is actually working. The next feature is RTSP over TLS, bringing encrypted video streaming to the IPC for the first time. RTSP is the protocol used to stream live video from the camera to any client, an NVR, VMS, or media player. Until now, that stream traveled unencrypted. With RTSP over TLS, the video stream is fully encrypted in transit, meaning even if someone intercepts it on the network, they can't view it. For installations where cameras are accessed remotely or where customers operate in sensitive environments, encrypted video streams are increasingly expected and, in some cases, required for compliance.
And that wraps up everything new in IPC firmware v5.3.1. As always, if you have any questions, don't hesitate to reach out. Thanks for your time, and we'll see you in the next one.